Okay, so very good evening. So we meet again for chapter number 4, part 2 on radio transmitters. So yesterday we have seen part 1 on the introduction to transmitters, what are the components, what are the types, and how we can choose the transmitters. Okay, so today we will continue from where we left yesterday in part 1. Okay, types of AM transmitters. Okay, there are various type of amplitude modulation transmitters. Okay, so we will call it as a low level modulation transmitters and high level modulation transmitters. Okay, so what's the difference if we say in a layman term? Okay, low level means it's not so complex, and high level is a bit complex. So more complex modulation transmitters. So basically, the construction of a low level modulation will be much simpler than high level modulation. So again, when we choose the types of transmitters, so we need to determine where we want to use, for which application we want to use. Based on that, we can know whether it's a low level or high level. Then we can buy it accordingly. Okay, so we will see low level modulation transmitters. So this is the block diagram. So we can see on top, it starts with stabilize RF oscillator. So yesterday we have seen the function of oscillator is to generate the carrier signal. So the signal that will carry your message. Okay, so this is the transportation for the wave. Okay, so the oscillator will create the carrier signal. So it will be amplified, and here it will be your message. So or we call it as a modulating signal. So your message. So for example, your speech or any sound. Okay, so it will be audio process. So it will be filtered. It will be amplified. The modulation we know. So your carrier signal will will join with your message signal. So then it will be modulated, it's amplified, power amplified, and it will be passed to the antenna. So this is typically a standard procedure for modulation and transmission. Okay, so we consider this is like a basic modulation, a modulation transmitter. Okay, so from your antenna, so it will be transmitted to the receiving antenna. Okay, so this is the simple block diagram that you need to understand. Okay, so we have some pictures on top. Okay, so this is a carrier signal, so it's generated by the oscillators, and this is your message signal, so it's having like a sine wave, and this is the modulate modulated signal. So modulated signal and modulating signal are two different things. So modulating signal is your message signal. Modulated signal is the modulating signal combined with carrier signal. We call it as a modulated signal, ED, modulated. Okay, so it will be further amplified. So this is a linear amplification. Okay, and power amplification usually will be for transmission. Okay, so then it will be pass. Okay, so low level modulated transmitters. Okay, so high power. Okay, high power is not amplitude frequency uh, is not required. Okay, and the design is much simpler. Okay, so as I say, yeah, the design is much simpler because it is not. Yes, any question? Okay, so the design of a low level AM transmitter is much simpler. Okay, so we can see some of the advantages. The AM transmitters are less complex. Okay, because it's having lesser component. So AM receivers are simpler. Detection is easy because it can be transmitted over a certain distance, a long distance, and the detections can cover a larger area. So the AM receivers are much simpler because you no need to have a sophisticated or complex circuit or antenna to receive it. So the detection is much easier. So AM waves can travel long distance. So usually it can travel more than 50 kilometers or 100 kilometers or a few hundred kilometers away. And it only requires a uh, low bandwidth in comparison with frequency. So if you can see disadvantage, AM still needs a larger bandwidth, but much lesser than frequency modulation. Okay, so the disadvantage, so all these are advantages and disadvantages. So there will be a lot of power wastage will take place. Okay, so usually the power wastage will be because of um, a lot of factors. Okay, a lot of factors like transmitter design. So it can be high voltage in the power supplies. Okay, so yesterday we have discussed as some questions on why electrical and also electronics. So there can be a lot of high voltages involved, and it can be because of amplification and losses in between, losses in terms of heat generated or insufficient antenna matching or tuning, so heat dissipation. So all these will cause a power wastage to take place. Okay, so AM is not much preferred in that sense. So AM get affected due to noise. So we have known. So when there are smaller distortion or changes in the signal, the overall message that will be delivered will be changed. Okay, so as I say, so let's say you are sending A. So because of distortion, it become AA. So then there will be addition of uh, minus in the signal that will be delivered. Okay, so AM practically need a larger bandwidth. So just right behind if you have your hard copy notes. So compared to frequency modulation. Okay, so applications that we always use AM will be on the radio broadcasting. So those time, so we use AM. So now we are more for radio broadcasting. We are using frequency modulation. Okay, so very seldom we are using AM, even though in our car we have AM and also FM. Okay, so we picture transmission in a TV system. Okay, let's say you just want to transmit was a picture, so not a movie, just a picture. Then, so you can use AM, AM for transmission. Okay, so earlier we have discussed on the low level modulation transmitters. So now high level modulation transmitters. So we can see more blocks are involved. So it starts with, okay, maybe I just open all the pictures. Okay, so you can see, so stabilized by RF crystal oscillators. Okay, so crystal oscillator will generate the carrier frequency. Then the carrier frequency will have amplification. So class A amplification. So we have seen yesterday what is class A, class B, class C. Okay, so class A is less efficient. Class C is more efficient. So it will be amplified to less efficient first, then to power amplify to more efficient signal before it pass through a modulator. So down here is your message signal. So audio process is amplified. It does, it involves more amplification. Okay, so amplification you can do at one shot. Okay, let's say from 1 you want to amplify to 1 million, so you can use a powerful amplifier to straight away amplify, but there will be signal losses in between. So there are possibility, and it might requires lot of energy, and also it can be dissipated. So what usually we will do, so we will use a intermediate amplifier in between, okay, which is less efficient. So once it amplify, it will be further amplified. We call it as a nested amplification. A nested meaning is in a loop. Okay, so class A, so class B amplification. Okay, so here you have a carrier signal, here you have a message signal, then you have a high level modulator. Because both signal are already high level, so it will be combined to form a high level signal, okay, or modulation. Okay, and it will be transmitted to the receiver. Okay, so I just want to show you all about the difference between class A, class B, and class C. So if just to refresh you, so you can see class A, usually it will send the entire input signal, and because it's sending entire signal, so there are a lot of wastage, and because of that, low efficiency. Why it can have a lot of wastage? Because not all signal or all points in the signal as information. So some can be noises. So when you are taking the entire signal, so you are taking in inside a noise also, and you need to have a noise reduction system in order to remove the noise after that. So it will make class A transmitters to be a low efficient. Okay, so usually will be less than 50 degrees, 50 degrees efficiency. So class B, so it's only taking a certain portion, okay, and maybe the first half or the positive half of the signal. So it will be 50% of the input. So the other 50 down here negative, so it will be removed. Remove. So when you're transmitting it, so the efficiency will be around 78 to 79 percentage, but much higher than class A. And class C, so you're only taking a certain portion of the signal which has the information. So you only amplify this and you transmit it. So because of that, the efficiency is much higher, so above 90%. Okay, so that's the difference between class A, B, and C. Okay, so we go back to the previous one. Okay, so I think I already explained A, B, and C. Okay, so high level modulation transmitters. So many of the AM transmitters uses the high level modulation technique. Okay, so mostly we are using high level. So very seldom we use low level because we cannot achieve a lot of application. Okay, so crystal oscillator produce the required carrier signal. So all this I have explained. Okay, so the class A amplifier following as oscillator acts as a buffer which isolate the oscillator from the high power circuit. So as I say, so it will be uh, amplified by a less efficient amplifier first, then it will go to the high power. So it is to reduce. So it act as a buffer. Buffer meaning is something in between, like a sponge. So it give a damping effect. So not a sudden rise of power. So when you have sudden rise of power, there can be a lot of losses. Okay, so the output of this class A amplifier is applied to the class C power amplifier. It raise the power level of the carrier yeah, to an intermediately high value. Okay, so AF modulating signal is applied to the audio processing unit, which processes this signal as discussed in the previous section. Okay, so a modulating signal, that is our message. So it goes through audio processing amplification, and once it's ready, it will be combined with the carrier signal to form a high high level modulating signal. Okay, so the advantage of high level modulated transmitter, so is is high efficiency due to the use of class C power amplifier. Okay, so class C is a very efficient power amplifier, but usually when we are using more efficient equipment or component, usually the cost will be higher. Okay, so uh, if you are ready for high cost, then you can consider this. Okay, so there's a advantage. So it can become high efficiency due to the class C power amplifier. So and the disadvantage, large power amplifier is needed to raise the modulating signal to a desired power level. So because earlier if we see, so we only use class C type of power amplifier for the carrier signal, but for our message signal, so the modulating signal, we only use up to class B. So due to that, so you need to use maybe another uh, class B or class C amplifier after that to raise the level. Okay, to raise the level, similar like power, uh, similar like the class C type of power amplifier. Okay, so the comparison between low level and high level modulation. Okay, so you can see we have around 5 points for us to discuss. Okay, so first in terms of power level, so modulation is carried out at a low power level. Okay, for low level modulation, the power level is very low. Okay, so very low. So at times, if your application requires a low level modulation, then you can consider. So other than that, so usually we will go for high level modulation because modulation is carried out at the high power level. Because most of the transmission, so we need it to be high high powered, high powered. So we usually will go for this unless required for low level. Okay, the second point, amplifier stages. Okay, so low level, so we see only need like one or two. Okay, so not many. So need lesser amplifier stages. And for high level modulation, we can see even the carrier signal requires modulation amplification, and even the message signal requires amplification. So a lot of amplifiers are needed. Okay, so when you are using more amplifier, so the costing also will be higher. Okay, then power efficiency. So after modulation, linear amplifier can only be used. This gives a lower power efficiency. So linear amplifier meaning, so if you give A, it will give B. So it's already like predetermined. Okay, predetermined. So you give this input, you'll get this output. So that is what we call as a linear amplifier. So non-linear amplifier usually we will use in high level modulation. So non-linear meaning is not linear. So it can be reciprocal, so it can be logarithmic. So meaning uh, if you give A, so it will decide. So it will have some intelligence inside or some formula inside to calculate according to your input. So it no need to be A. If you give A, it must be B. So it can be different uh, output depending on the formula or the analysis done by the amplifier. So meaning the amplifier, non-linear amplifier, is much smarter than linear amplifier because it can predict or it can adjust the output based on the input. Okay, so usually high level modulation will use nonlinear amplifier, and it because of this adaptability, so it leads to high power efficiency. Because when, so let's say you are charging your phone, So you are using usually we will use a linear charger, because you just plug into your power socket and you just plug the cable to your phone. So whatever output comes from the electrical or electronic charger, so it will just enter to the phone. So the if it's linear, so it will keep on taking input. It will keep on taking input without doing much analysis inside. If it's a smarter non-linear amplifier, okay, so the charger can be much smarter. So it will charge when it reach certain level. So let's say it's already fully charged, automatically it will off. So that is adaptability. So it has some smart elements to the amplifier or the charger. That is how. So non-linear amplifier, it has additional feature which can give some advantages. Okay, then in terms of power losses, so power losses in amplifier is higher for low level modulation. Why power losses are higher? Because most of the power will not be utilized properly and it will be converted to heat. And because of the amplifier, so the amplifier will become hot, and it will the electrical energy will be converted to heat energy, and it will be released to the environment. So power losses will be higher, and because of the heating problem, so there's another problem associated, which is the cooling problem. So because if equipment or your component become too heaty, so you need to have a cooling system or cooler attached. So it will incur additional costs for you. Okay, so for low level modulation, that we have another new problem, which is the cooling problem. Okay, but in high level modulation, so the power losses is less, because it has some smart elements inside, as I said. So it can adjust and it can predict certain things, and it can control. It can do damage control by itself. So the power losses is less. So you don't maybe the power losses will be there, but much lesser. So once it detect there's a power loss, it will try to adjust itself in order to reduce it. So here the cooling problem is not happening. So I won't say not happening, but is not severe. So very less. Okay, so very less. Okay, and the fifth one, in the application wise, so low level modulation usually used as a higher power broadcast transmitters. Okay, so let's say you want to have a very standard pattern that you want to transmit from a transmitter to receiver, then you can consider a low level modulation, because you don't have any much changes in between. Okay, but high level modulation, so we usually use for TV transmitters, and also more sophisticated like radar or satellite. So we'll use a high level modulation. Okay, so these are some of the comparison between low level and high level modulation. So we need to decide. We need to decide: are we working on low level application, or are we working on high level application? So if accordingly, we need to decide which type of transmitter that we want to use. Okay, so then we enter for to the fourth subtopic. So the FM transmitters. Earlier we have seen on the amplitude modulation transmitters. So now frequency modulation transmitters. So it has a certain power amplification and also modulation techniques involved. So in FM transmitters, so we know we will be using frequency modulation technique. Okay. So in FM, frequency of the carrier is varied in proportion with amplitude of the modulating signal. and keeping its amplitude constant. Okay, so we know, we have seen in chapter 3 how frequency, the difference between amplitude modulation and frequency modulation. So amplitude modulation, we are varying the amplitude of the carrier signal, but in frequency modulation, so amplitude will be the same, we just varying the frequency. Okay, so usually frequency modulation transmitters we use in radios, so we'll use in TV sound broadcasting, so police wireless transmission, so more broader specs, and also more stable communication needed, then we will use FM transmitters. Okay, so in FM transmitter, the FM signal is transmitted by a transmitter. So whatever signal, you must use a transmitter to transmit. Okay, then you need to have a receiver to receive. Okay, so the information is contained in its frequency variation. So the information will be modulated into the carrier signal in terms of frequency variation. Okay, so you can see, much complex than amplitude modulation. Okay, here you have a crystal oscillator, and you have a buffer amplifier. So here you have your message signal, so enter the audio processor, amplified, then it will be combined in the modulator. Then you have frequency multipliers, and mixer, then power C is a class C power amplifier. Uh, so here you are using another carrier signal. Okay, so this more on the complicated FM FM transmitters, and it will be transmitted to the antenna. Okay, so not all application will have this thing. So maybe after this phase modulation, so it can have a simple maybe class A power amplifier, then class C power amplifier and antenna. Okay, so all these are additionals. Okay, so for frequency modulation, so what are the advantages? Okay, there are some advantages. So improve noise immunity. So noise immunity means, so it prevent noise in the transmission. So that's why even when we hear a radio station, okay, radio transmission in the car, even you are traveling, it's still stable, so you cannot get a lot of noise, because FM it has a improved noise immunity, and entirely transmitted signal is useful. Okay, because you are not varying the amplitude. When you vary the amplitude of the carrier signal, then it will become like a customized transmitter signal. So meaning once you deliver it, you cannot reuse again. You cannot like send a lot of information inside when you change the amplitude. But when you maintain the amplitude but you vary the frequency, so you can send different signal at a different frequency level. So it makes the entire FM transmitted signal to be useful. So you can, because you can send a lot of things. Okay, and it covers larger area with the same amount of transmitted power. So this we have seen in chapter 3. So the power will be the same. Okay, and it covers a larger area compared to AM, and the transmitted power remain constant. So this one advantage, because we are concerned about how much power, because when you are using more power, so one side it will generate more heat, so energy will be lost. Another side on the costing, so you need to constantly change the uh, components, equipments, and it will create more cost. At the same time, electricity also will give you more electricity bill. so you need to pay more for the electricity. So that it's very important to use FM, because the transmitter power will be the same, because we are not varying the amplitude. When you vary the amplitude, maybe you require more power. So is one of the advantage of frequency modulation. But there are some disadvantages also. So it requires very large bandwidth, because when you're dealing with a bigger frequency range, then you need to have a larger bandwidth, because the maximum frequency and the minimum frequency will be uh, huge in gap. The range will be higher. Okay, then the FM transmitters and receivers are very complex, because the construction, because you are dealing with frequencies. So when you are dealing with frequencies, so you need to have like a frequency analyzer inside to determine which frequency. So a lot of things, and because of that, the transmitter and receiver will become more complex. So when we it become more complex, so it will become more costlier. Okay, so that's some of the disadvantages. Okay, so the application of frequency modulation, okay, radio broadcasting. So like how we are hearing the radio in the car, a sound broadcasting and TV. So our TV system, satellite TV and satellite communication. So when we want to communicate with outer space, so and satellite GPS, so all these are related to frequency modulation. Okay, some comparison between amplitude modulation and frequency modulation broadcasting. Okay, so for AM, it requires smaller transmission bandwidth, okay, much smaller than FM, because FM it deals with megahertz or gigahertz, but here it's only hertz to maybe megahertz, so it's much smaller bandwidth. Okay, and it can AM can be operated in low, medium, and high frequency band. So usually when it consider like mm, megahertz, so it's already high frequency. So low frequency meaning in hertz, maybe like 5 hertz, 10 hertz, 20 hertz. So even our human hearing ability is between 20 hertz to 20,000 hertz. So we our hearing frequency range is not so high. Okay, not so high. Okay, so AM can operate in low, medium, and high frequency band, but FM it operate in very high and ultra high frequency as frequency band. So meaning few hundred megahertz or gigahertz. So it will be operating in that kind of range. Okay, so AM, so it has a wider coverage, because it's already sufficient to operate in low, medium, and high frequency band, but and it can travel a longer distance. So that's one advantage of AM. But FM, its range is restricted to 50 kilometers. So you cannot operate over a very long range. Is depending on the surface also. If it's a very hilly with a lot of mountains and hills, then maybe this range will be much shorter. Okay. So that's why you can see in the car. So let's say you want to listen to its FM. So maybe in the northern area, the frequency will be different. So once you reach Ipoh, you need to change the frequency. So once you reach KL, you need to change the frequency. So because the frequency range is restricted, so depending on the coverage, okay, depending on the surface of the geographical surface and everything all contribute. So FM, it has a restriction in terms of the coverage, wider coverage. Okay, then we continue. So demodulation is simple for AM because it's only amplitude. It's not dealing with frequency. So you just decode it. So you already can demodulate. But for FM, the process of demodulation is complex because you need to, because the frequency range will be higher, so wider. So you need to really make sure that you are dealing with the correct frequency in the modulation. If not, uh, things might lose. Okay, or it will be altered. Okay, so it's quite complex for the modulation process. So the stereophonic transmission is not possible for AM. So what is stereophonic? Stereophonic is how to explain this? Okay, so um, our human eyes are stereoscopic. Okay, so we have two eyes. Okay, two visions combined into one. Okay, so we call it as stereo means is two combined into one. Stereoscopic. So stereophonic. Phonic means sound. Okay, sound or phonic means is sound. So stereophonic means, so you have two sound sources combined into one. eh, so to give a better picture. Okay, like us. So let's say you just close your one eye and you try to estimate the distance. Uh, it will be tough for you if you only use one eye. But when you have two eyes, so it will give a stereoscopic view, so different perspective in order to see things, and you can estimate the distance by just looking at uh, the the matter or something that you are looking to. So you can just touch without thinking because you already can estimate based on your stereoscopic vision. So stereophonic is almost similar, but it's on the sound. So you have two sound source. So you send signal, and the signal will be combined to estimate. So what are the things in front? So it's more like an ultrasonic kind of concept. Okay, it's not possible in amplitude modulation because you are altering the amplitude, but is possible in frequency modulation because you can play with two different frequencies. So maybe the first stereophonic device can send at a certain frequency. Second stereophonic device can send in a different frequency. It can be combined to estimate the message. Okay, so that is possible in FM because it's dealing with frequency. Okay, and for AM, the system has a poor noise performance, so a lot of distortions happens, and it can alter the final message. But in FM, it has a improved noise performance, so a lot of noise cancellation, a lot of noise improvisation. Okay, in order to deliver the exact message that you are sending. Okay, so we will stop until here for today. So any question? Okay, so today we have seen about AM, FM, low level modulation, high level modulation transmission. Is there any question that you want to ask?
No, sir.
No, sir. Okay. So no question. So